Problem 5.3.27. Use Thevenin theorem to find I sub 0 in the circuit. So for this problem, we have dependent voltage source and independent voltage source. So if you have an independent voltage source, we can just make it short circuit when we calculate RTH. However, the dependent source, we cannot do that because it is dependent on some source values in the circuit. So we need to isolate I sub 0 component. I sub 0 is going through here, right? So we have to take that out. If we draw the circuit, it looks like this. Our goal is to find VTH. Where is VTH? Right here, okay, in the middle. So the first thing we can think of is doing KVL, right? Because we know this node is Vx. Okay, we have a positive at the top, so it's a Vx. And we can let this guy as V1. Then that KVL will give us negative Vx plus VTH plus V1 equals to 0. And VTH equals Vx minus V1. So now we need to find Vx and V1. VTH portion is open circuit, so we need to calculate Vx and V1 separately. So for Vx, for this side, we can use the voltage division. We have 4K over 2 register, combine the 2 register, 4K plus 8K, and then total voltage 12, and that is 4 over 12 times 12, which is 4 volts. For V1, same thing, we can use the voltage division. For V1 equals that one over that plus the other, and then total voltage Vx. So we have a 4K over 16K times 2 times Vx, and 4 over 16 times 2 times what is Vx? We just calculated, which is 4. So now it's 4 and 4, 4, 4. So now V1 equals to 2. Then we have a VTH equals Vx 4 minus 2 and 2. So we found the VTH. Now we need to find RTH. For RTH, because of the dependent voltage source, we cannot find the RTH. Therefore, we're going to find IN, the Norton current first. We have a VTH over IN. That'll give us RTH. We need to insert short circuit in the VTH location. If we do, the circuit looks like this. So we have a circuit like this, and we need to find I sub n. So what do we do? This IN, this is the whole node, one node, and we do know this is the node for Vx. That means this whole thing is Vx. And let's do the nodal analysis. I'm gonna just outward, just like we said in class. So I'm gonna put all the current outward and the node Vx. We're gonna do KCL, right? So everything is leaving, and we need to put it in V over R form. So the voltage, the first one, the left side, Vx minus 12 over 8K, because we do know this node is 12, and it is a positive because it's plus at the top. And downward, Vx over 4K. We have another Vx over 4K. Second Vx is this one, and plus, I just fixed it 12K on the top one. So now if you want to find out for the current this one, then we have Vx, and this node is 2Vx, positive 2Vx minus 2Vx over 12K. So now we need to multiply everything by 24k so that we don't have the denominator value. 8 times 3 is 24, so 3vx minus 36 plus 4 times 6 is 24, 6vx plus 6vx, and then plus 2 times 12k is 24k, so 2vx minus 4vx equals to 0. 3, 6, 9, 15, 16, 17 minus 4, 13 vx equals 36. Therefore, we have a vx as a 36 over 13. Now, we need to find I in. I in is going in that direction. So, we want to do KCL at Vx. They are all leaving I sub n plus leaving Vx minus 12 over 8k, that's the leaving, and another leaving Vx over 4k, that's the leaving, equals to 0. So now we have I sub n equals, let's combine these two together, negative 1 over 8k. We have a Vx minus 12 plus 2Vx. That is negative 1 over 8k. 3Vx minus 12. Then I sub n equals negative 1 over 8k. 3 times Vx. We have 36 over 13 minus 12. And then use your calculator and find the value, and that is positive 0.46 milliamp. RTH equals VTH over IN, and VTH we found 0.46 milli. That'll give us 4.33k. So now put it into Thevenin circuit. We have plus minus VTH, which is 2, and then RTH equals 4.33k. And then put the value, okay, 2 kilo ohm back in here, 2 kilo, and then this is I sub 0. Therefore, I sub 0 equals 2 over 6.33k. That is 0.316 milliamp.